algebra students, this is our introduction video for our lesson on graphing from standard form. The focus of this lesson is going to be on how different parts of your equation in standard form affect the graph. And for this lesson, we're going to be using our website Desmos to help us make some observations. The four things we are going to look at are these four things in this table here. We are going to start our graph with the equation y equals x squared. So this is our starting point of our graph. And we're looking to see if we notice how these four things will change the graph. So that first one is going to be how that constant term, that c number in your standard form, changes the graph. And so for example, if instead of having y equals x squared, I had y equals x squared plus 3, or y equals x squared minus 5, how those numbers would change those graphs. This is one that we've looked at in previous lessons, so if you think you know, go ahead and make your prediction now. I'm going to leave our y equals x squared there and graph another line, and instead of y equals x squared, I'll do y equals x squared plus 3. So there's that graph, and we'll do one more. Y equals x squared, this time we'll do minus 5. And not y plus, y equals x squared minus 5. And we've got that graph there. So looking at that red line as our starting line, how do those constant numbers change the graph? Well, they change our y-intercept. If I put plus 3, my y-intercept is 3. If I put minus 5, my y-intercept is negative 5. So how does it change the graph? It is our y-intercept. Off to the side, you might draw yourself some examples. So for example, if this purple line is y equals x squared, then this green line here might be y equals x squared plus 3. It moves it up to the number 3. The next thing we're going to do is look at how the sign of a affects your graph. A is that number in front of x squared. So first, how positive numbers greater than 1 affect the graph. So for example, y equals x squared. And then we'll look at negative numbers. So if you have something like negative 2x squared, how those affect the graph. If you've got some predictions, go ahead and make those now. And let's look at both of those examples here. So again, y equals x squared is our starting point. If we do something like y equals 2x squared, that's that purple line. Do you see how the graph changed? We can do a couple more. What about y equals 5x squared? Or even bigger, y equals 10x squared. Do you see what's happening to our graph? Well, every time I make that number bigger, the sides of my parabola get closer together. We have a parabola that's more narrow or skinny. And so when that number is greater than 1, we can say the parabola is more narrow. Or in the past, some people have said the sides of the parabola are closer. So again, I'll have y equals x squared here in purple. If we think of that as like our starting point, if I add a number in front, like 2x squared, it makes the sides of my parabola closer together. We still have that same y-intercept because I didn't change the constant. Our sides are just closer. If we make those numbers negative, like negative 2x squared, you might already see what's happening. Negative 5x squared, negative 10x squared. What's happening to my parabola? It's going the other way. So when that number in front is positive, your parabola goes up. And if that number in front is negative, our parabola, we use the word faces downward. That just means it goes down. And so if this right here is my y equals x squared. If I were to put a negative sign in front of it, negative x squared, it just means my parabola is going down instead. There's one final observation, and I'll get rid of all of these, and that's if you have a number in front that's smaller than 1. So we did numbers greater than 1, like 2, 3, 5. Numbers less than -1, like -2, -3, -5. This final one is looking at numbers between -1 and 1. So that would be, for example, numbers like a half, 1/2 x squared, or -0.2 x squared, those smaller numbers. We know these bigger numbers makes it more narrow, but what happens with those smaller numbers? If you have a prediction, go ahead and make it now. And I'm going to start with a half. 1/2 x squared looks like that blue line there. And then we could maybe do a decimal. Y equals 0.2 x squared is that green line. So if we're keeping in mind this red line is our starting point, our x squared, what's happening with those smaller numbers? Well, the opposite. If larger numbers brings the sides closer together, smaller numbers are bringing those sides further apart. So we could say our parabola is wider. This is wide, this is narrow. And so for that final example, I might say, again, if this purple line is my x squared, then if I were to do y equals 1/2 x squared, it's going to be, the sides are going to be further apart. So maybe that's y equals 1/2 x squared. And then similarly, if I were to put a negative sign in front, that same thing is true, it's just facing downward. So you could also, if you wanted, to draw another one and say this one here I just drew is -1/2 x squared. The focus of today's lesson is going to be graphs in standard form, so equations like these, and how these 4 things can help you identify graphs, and also how you can use this knowledge to help you match different graphs to their equations. Thanks so much for watching. You're ready for today's lesson.